Our first presenter is Megan Salter. I hope she's going to tell us about how she became the Teacher of the Year and all those things. But she is a woman to watch in the Women in Drones. And she's a very accomplished teacher, and she has a lot of great things to tell us about an elementary program in drones. So go for it.
Hi, make sure that my mute is off and everything so you can hear me. Give me a thumbs up. Yeah, you can hear me fine.
Yep.
Okay, there we go. Hi, everybody. So what he was saying, my name is Megan Salter, and I am a elementary school teacher in Huntington, West Virginia. Where I live is pretty much where Ohio, Kentucky, and West Virginia meet. So it's the tri-state area. I've been teaching for 12 years now, and I've been implementing drone curriculum into my classroom the past 4 years. Kind of how I got into this was by accident. A good friend of mine visited my classroom, and he brought this thing with him. And I was like, what is this? And, it was a drone. And I noticed just how enamored my kids were with the technology. And I said, I've got to get some of this for my classroom. So since then, I've written several mini grants to purchase some drones for my classroom, like DJI Tello drones and some of the equipment that goes with it. Because if any of you know anything about public schooling, they give you a little bit of money for supplies, but drones are not really in the supply list. So I've been implementing drones in my classroom the past 4 years. I do it with students first all the way through 5th grade, although 5th grade is what I normally focus with, because the 5th graders, they start putting together an entire portfolio at the beginning of the year where they have, all their written assignments, and they're learning like the native phonetic alphabet and everything that you would do to get your Part 107 license. And at the end of the year, we do this big event where the whole community is invited, and it's called a Drone Olympics. So I'm going to show you a video of that here in just a minute, but I'm going to go ahead and share my screen here. All right, make sure I do this correctly. All right, what I'm going to show you right now is, let me bring up my PowerPoint. All right, so I'm going to go ahead and start. So drones in the elementary classroom, a lot of people, that's kind of a scary concept for elementary teachers, because we are used to, giving kids safety scissors and, things like that. But students are very capable of doing things like this in the elementary classroom. And it's very safe as long as you implement the rules. And I'm going to talk about the rules that I have in my classroom for my students. So what he was saying, I am a nationally board certified teacher. I am a Part 107 certified drone pilot. And I was named 2021 Cabell County Teacher of the Year, and I was one of the top 5 finalists for West Virginia State Teacher of the Year, which was pretty exciting. But you can see in this picture here, so this is my classroom, and you can see there's a little DJI Tello drone up in the top, and you can see at the back parts of the drones and the stuff that my students were learning. A cool thing about using drones in the classroom, just a hint for you, teach 1 or 2 kids how to use the equipment properly and have them teach other students how to do it. I do have another video we probably won't have time to show you, but it's these 2 kids. So I've got the little girl right here, and she is my flight instructor. So you see she's got the clipboard there, and she's teaching the other student all of the moves and everything he needs to know, of like connecting the drone to the iPad and all that stuff. So I can sit back, once I teach 1 or 2 kids how to do this, I can sit back and I can watch. And it's really impactful for the students to be able to do something like that too. Oh gosh, that's the same little girl. I just noticed that. So yeah, this little girl's in 5th grade, and here she is when I think she's in 2nd grade right there. So you can use it with students all the way, 1st, 2nd, all the way up to like 5th grade. When you're introducing drones in the elementary school, you need obviously the drones. So the DJI Tello drones are great to use, or something that is similar to it. And other materials that you might need are iPads. I doubt if they have iPhones in elementary. But if you are using an iPhone in elementary, it's really helpful to have a controller that hooks up to your iPhone, because I've noticed that kids with little hands, sometimes it's very hard to control the drone with a giant iPad. As far as classroom safety goes, these drones are very safe, The one thing I always make my students do though is wear safety glasses. You can see this kid right there has safety glasses. I don't make, if the students already have their own glasses, I do have goggles for them, but that's the only thing that I really worry about, because these Tello drones, they are tiny, they're very durable, they can run into things, and you know they're fine. A propeller might fall off. But that is one thing that I always emphasize. If we get these drones, you always have to have eye protection, because I've seen several times where kids have crashed a drone and we have a propeller that flies off. Well, what is the most, vulnerable part of your face? It would be your eyes. So I always make them have safety glasses. And it's always a good thing to remember, if you're a girl with long hair, put back your hair, or a boy with long hair, because it is not fun to try to get a drone out of your hair, and it makes for a giant mess. So, but these drones are extremely safe. I even demonstrate with the kids how even with the propellers, you could stick your finger in it. It would hurt, might give you a little cut, but other than that, you should be okay. As far as adapting this to different areas of the curriculum, there's so many ways that you can do this. When I started about 4 years ago, I had to be pretty creative, because there was very little curriculum to start with this. So my students actually helped me. And I started, I said, well, let's talk about the parts of a drone. And we went from there, and then we started talking about the physics of flight, the native phonetic alphabet. And each year as I do this, the students, we're learning how drones are evolving and how they are changing as far as helping humanity. Because that's one of the big things that I want to emphasize with my students, is how we can use drones or technology for better. As far as organizing organizing your classroom tips and tricks, like I said earlier, give your kids jobs. It doesn't matter if you have elementary, middle school, high school, it does not matter. As long as you have jobs for all the students and to keep them engaged, your behavior levels are going to go down, because they have something that they need to focus on. So I might have one student who is the pilot in command. I might have another student who's the visual observer. I might have another student who's the safety specialist, and another student who is documenting scores on the board, timing, anything like that. So it doesn't matter what grade level you have, as long as you keep all the kids involved and give them a job, then your behavior should be minimal, bad behaviors. And just implementing drones in the classroom, period, that is a behavior incentive for the kids to act correctly, because they get really excited to use this technology. So materials, like I said earlier, you need like an iPad, an iPhone, a mini drone such as a DJI Tello. I like the EDUs because you can use those to code. I don't believe the DJI regular Tello drones, you can code with those. Safety glasses are a must. Also, extra batteries and propellers. That could be something that your safety specialist, your student, could do. Make sure you always, have the batteries that are charging. Make sure that when you do, just like if you're flying outside, make sure that you have that drone, you check the propellers, you check your surrounding areas, any things that might come into contact with your drone. I also use, because like I said, I'm in elementary, but I also have a very low budget. We use fun things like hula hoops, pool noodles. They are all very inexpensive, and it doesn't matter. You can use these things inside, outside. They're very durable, and it's a fun obstacle for the kids to be able to do. So as far as adapting for different grade levels, so you can see that I use it first all the way through fifth. You can adapt it into so many different curriculum and content areas as long as you're creative. I really emphasize with my students with their portfolios and writing things down. So you can see that the little kid in the middle there, that's my classroom. I went down to my gym teacher's office and I stole some cones and I had some duct tape and we had pool noodles. And the kids had to fly through that. That was one of the obstacles they had to do. You can see right here on the side, the two girls, I have a little 3D pen that the students are designing something to attach to the drone to carry one thing, like the payload from one place to another. Also really interesting with the writing component, this image that you see on the left, that came from 4 years ago. So that's my first group I did this with. So drones have progressed, immensely since then. So the writing prompt was, how do you think that drones will be used in the future? And this kid said, I believe that they'll use drones to help save victims who are drowning. And sure enough, a few years later, that has already been developed. So it's really interesting the types of things that your kids are going to be able to see that you might not at that time. But they're very creative, and it's just a really cool experience for them to be able to do stuff like that. Other things, as far as organizing your classroom, obviously I said safety glasses are a must, and long hair needs to be pulled back. You can see right here, this little girl was my flight instructor, and she got her own little badge, and she's got her clipboard there. Establish safety rules, behavior contracts. I have my kids, we sign a behavior contract, and I tell them if they're doing stuff they're not supposed to, I say, you're grounded. And they get that because, you know, as a kid, if your parents say you're grounded, you can't do something, right? So when I say you're grounded, it means you are grounded from flying the drone until you can prove that you can be responsible with it. And also, we do have those students who are very competitive. And we have to say there's no crying and drone flying. I don't care. We're not going to, you know, whine about it. So those are my two big sayings that I have, and behavior contracts is a must because, and I tell my students too, I say, you know, as long as we're safe with this stuff, we can use it. Also, another thing, if you have multiple Tello drones in your classroom, there's a serial number inside the hull of the drone. If you are trying to use more than one drone at a time, you have to put that serial number on a sticker or something and put it on the outside hull of the drone, because I've experienced where I had multiple students plugging in or, you know, connecting their Tello drones, and everyone was controlling everyone else's, because when it shows up on your iPad, it just says Tello and this weird number. So that is something that I learned that would be a good hint for anyone who's thinking about doing this. Like I said earlier, grouping students, make sure they each have a job, and definitely train student flight instructors, because depending on how many students you have in your classroom, it is difficult to be everywhere at once. Okay, so Ken, do we have time to watch this, or do we need to move on to somebody else?
Oh, we have time.
Okay, all right. So, and I have a little video, which we don't have to show that if we don't have time, but of the two kids that are, I have the one kid that's being the flight instructor to the other one. So let's see if this shows here. Oh, wait, I should probably stop. So this video right here is the county that I work in. A few years ago, they did a drone Olympics, like a Cabell County Connection. So they had someone that came and they filmed the drone Olympics that I had at the school. So this is what I told you, that my 5th grade students at the very end of the year, this is their big celebration that they do, that all the community and everyone's involved with. And all of my students, we have, I think there was like 4 or 5 events the kids competed in. So we put them in teams, they had tie-dye shirts, they had team names, all this stuff, and we have the scoreboard. But every event that we have in there represented a real world application for how drones are being used or will be used in the future. Like one was a payload challenge, and we used Legos. So you're going to see a bed sheet that is painted with a bullseye, and you can see kids moving the Legos from one place to another. So that is what this video is, and it's 3 minutes and 33 seconds. And you're going to be able to hear, obviously, myself speak and some of the students about the types of things that they learned.
The Drone Olympics, this is the 3rd year that we have done it. My students have been learning about drones, unmanned aerial vehicles, and the physics of flight. So today was to kind of celebrate and to show what the students have learned over the past several years. Had 8 different Olympic events that all relate to real-world applications with how drones are being used. And the students competed in each one of those events, and they had a great time.
It was really fun. I loved competing with all my friends. My favorite part was flying through the gauntlet.
I thought the drone Olympics were fun. You still learned how drones are being used in real life, how they could be used in the future.
So the students, each event simulated a real-world application. Like the one with the gauntlet, we talked about drones that intercept other drones that are in prohibited airspace. We had another one with the accuracy and precision challenge. So we talked about how Amazon is using Amazon Prime to start delivering packages. They're in the process right now of developing those things. We've also talked about other ones with like drones that are delivering life-saving equipment and things like that for people in need.
I didn't know they had like drone taxis, like construction drones. I used to think that drones were just kind of like toys and just kind of played around with them.
We've been using drones in my classroom, created a whole drone curriculum that the kids have been learning. So today, the Drone Olympics, it kind of simulated them. The students actually kind of made their very own, their drone license. So they did all of the steps that someone would have to do in order to get an FAA drone license.
I loved learning the NATO phonetic alphabet. That was probably one of my favorite things that I learned. And then we learned all the terms of the different parts of the drones.
You get technology in the hands of kids and their attention span is right there with you. The kids walk in the classroom and they're like, are we flying drones today? What are we doing with technology? So it's completely natural for them. And I also, I want to reach them at a younger age so they know they're exposed to these things, especially being in Appalachia. We don't have the same experiences that other kids in other areas in bigger cities do. And my big emphasis is to get girls into STEM, get them interested, and also just expose our students here because they're completely capable. But get the technology in the hands of the kids and let them learn and do awesome things with it.
So I think it would be fun to fly drones around, but you would still be helping people do everything. You could help people do stuff while having fun.
This whole curriculum that I've been doing with the students has impacted the community. Last year, my students, all the students that you saw today, they helped with the ABC America's Best Communities competition. The students actually helped make, they took some of the drone footage that was used in the final presentation with Huntington winning. We've been using all of the technology that we have and try to get it out into the community. You give them the opportunity to do that stuff, they really take charge and they do a great job.
Okay, so that was the Drone Olympics that you just saw there. That was a few years ago. And the man that you saw in that video, that was my good friend who introduced drones into the classroom that I mentioned earlier. So we invite him back every year because the first year he really helped me with building the curriculum and everything else. So we invite him back every year to be our guest judge for the Drone Olympics, and he does a fantastic job with it. Unfortunately, due to COVID this year, when the craziness of school, we were not able to do the Drone Olympics last year, but we're hoping we're going to be able to do it this year. But as with everything, it's kind of up in the air. So that pretty much concludes my presentation. If anyone has any questions or anything, I guess feel free to put it in the Q&A. And thank you for listening.
Megan, we do have an interesting question in the Q&A. Do you need to get formal approval from your school district to use drones in your classroom? And what was that approval process like?
When I started, I did not, because no one really knew what drones were. It might be something you would want to ask, well, definitely your principal, first of all. My principal, when he knew, well, let me back up. He knows I always do a lot of crazy things in the classroom and innovative things. And he was automatically looking from a lot of logistic, liability perspective. This is going to chop children up, And I had to explain to him, no, it's not. Look at this. And I had to show him, and I had to, be like, this is safe. This is how we're doing it. This is why it's going to be safe. I also wanted, me personally, so I knew, and then anyone who were around me knew, I wanted to get my Part 107 license. So that way they know that I am licensed to do this and I know what I'm talking about. But that's just for commercial purposes. So I don't fly for commercial purposes, but I wanted to have that for me. As far as your district or whatever, I guess it would depend on whomever your safety person is, but I haven't had any issues with it because I just use the little drones and I use them inside in my classroom. But it would definitely let your principal know or some other people know before you start using them.
And this has actually sparked a lot of different questions. I think the video had a lot of great information for everyone. Can you explain the Running the Gauntlet event a little bit to us?
Oh, yeah. I forgot to explain that one. So we talked about how at that time, and this time still, how drones are really a big problem with people flying drones in prohibited airspace, like near airports, government buildings, and things like that. So we talked to the students about how there's technology that's being developed to either scramble another drone and cause it to drop, or a drone that has a net that would catch another drone. Now we don't have all that technology in my classroom for my kids to build a net and shoot it and get another drone. So I was creative, and I said, again, my gym teacher was my best friend during this, and I went and I raided his office, and I was like, "Ooh, handkerchiefs, that the kids use to juggle in gym class." So that is what my kids used for that, and it simulated that drone being in a prohibited airspace, and the goal was for the kids who are the safety specialists to get that, to ground that drone. So that's what that was.
And what were the 8 different activities that participants competed against each other in?
Okay, I don't know if there might not have been 8, there might have been 6. I might have misplaced that. But okay, so the first one would have been the precision and accuracy challenge. So that's the one that you saw with the Legos and the bed sheet. So that one, at that time, we were talking about how Amazon was looking to deliver packages and things like that. And we were talking about payloads. So whether it was a drone delivering safety or medical things to a disaster area, you have to be accurate and you have to be precise with that, because you want that delivered to the place it needs to be. So that was one activity that we did. So the kids had a certain amount of time. So they were spread out on each 4 corners of the gym. We started the timer, and they had a total of like 1 minute and 30 seconds to put as many Legos that they could on that drone so it was still stable, and fly it from where they were to the bullseye. If they were able to, like some kids, when they do it first, they start putting all these Legos on it and it just like topples over. So they have to learn about stability. So we practiced on that one quite a bit, but that was what that one simulated. The one where you saw the cups with my face on it, that was something that's kind of futuristic, I guess we could say. That was something fun for them. We called those construction drones. So you never know, there could be a drone in the future that can be used in the construction area if you're tearing down walls. I mean, who knows? A lot of the stuff that we didn't think would, be implemented now is, available for people to use. Another one was agility challenge. So that's drone racing league. So last year when we did our drone Olympics, we had hula hoops for the kids to go through. We had pool noodles. And I also went to my local car dealership and I asked for one of those giant inflatable balloon men, that you see out there. So we had that up and going, and the kids had to fly around that without being, hit and grounded. And then I also worked with a high school engineering class who does 3D printing, and my students, we built they designed a platform for the students to land on at the very end of it. I'm trying to think of some of the other ones. Then we have the gauntlet. I can't think off the top of my head because I didn't do it last year, the other 2 events, but they all, like I said, they all simulate real world applications for drones. And, each year we add different events because the technology is changing so quickly.
Excellent. So did you have to get special insurance for operating drones in the classroom, or is this something that's considered as a normal school lab?
I'm sorry, Carolyn, but I want to make sure LaQuata gets enough time.
Oh, okay.
So
I can answer that. I can type it.
Perfect.
Okay.
Great.
Awesome.
So if you want to continue to ask Megan's questions, you can do that in the question and answers. And Megan, thank you for taking care of those.
Thank you.
So I'd like to move on to older kids. So we have LaQuata Sumter here to talk about her middle school curriculum.
Hello, can you hear me good?
It's all yours.
All right. Can you hear me good?
Yes.
I'm gonna go ahead and share my screen. I'm gonna do desktop number 2, and maybe I should have done desktop number 1. Let's change it one more. There we go. All right. Tell me if you can see my presentation here.
And we can.
Yeah.
All right. All right. My name is LaQuata Sumter. I have a curriculum called STEAM Through Drones. I'm going to tell you a little bit about myself. I'm not only a FAA 107 remote pilot, but I'm also a electrical and computer engineering instructor, and that's where I spend most of my time teaching electrical and computer engineering. And I'm going to talk a little bit about my curriculum that uses electrical and computer engineering, actually. I'm also an instructional designer, and I'm a certified web developer as well. In the STEAM Through Drones, we have 3 curriculums that we have played around with and actually developed and taken from a couple of other companies that have developed drones. We've developed curriculums to go to them. The very first one that I started with before I got into the major developing of curriculum, the first thing I started doing was, we called it Drones Free Fly. And this is similar to Megan's Olympics. The Drones Free Fly is where we develop different activities for the students to fly through. I got into drones really looking for something for my college students to do differently other than play with robots, and I was looking for something new. So in doing that, I got into the drone industry, seeing that drones and artificial intelligence was new in the industry. I bought me one of the little drones, parrot drones, one of the little parrot drones. And I was like, this is interesting. And I continued to study it. And that's when I got the Maverick 2 Zoom. And as I got that drone, many of the schools around and organizations around the area in Southwest Georgia was asking me to come out and talk about drones and how they actually operate. So I partnered with Albany State University, and that's where I did my first curriculum set with middle school children from the Boys and Girls Club and from one of the middle schools in the area. And we did Drones Free Fly. And that's where we build out different components in different areas for the students to be able to fly through different technical hoops and loops, and actually basically drone precision flying, really. The next one is what I've been doing lately is discovery drones, where the students are actually building drones using Circuit Scribe, and I'll show you a little bit about that a little bit later and break down what we do in that. And then coding drones, we use Drone Blocks, and which is one of the most known drone building for programming drones actually right now. And we will show you a little bit about what we do in there. For our drone activities for the free fly, the things that we teaching there is basic drone knowledge. What is a drone? How does it work? The drone safety rules, ethics of the FAA. Then we get into drone physics, the different components and parts of the drones, and get into basic piloting and and then we get into photography skills. As the Tello drones have cameras on them, it allows the students to take pictures as well. So we teach them how to take pictures with the drone and actually build a company that they could possibly use at a later date. And then we look at real world applications, how the drone can be used to deliver and in construction, and how the drones are being used for survey and search and rescue and things of that sort. The drone coding curriculum, as I stated, we use Drone Blocks. Drone Blocks allows us to teach the students how to anonymously program the drones to do certain operations. I'm a programmer at heart, so I enjoy this curriculum as well. And I've kind of manipulated the Drone Blocks curriculum a little bit, added it into a Google Classroom for me to teach virtually now that we're in the pandemic. So students are able to go through the Google Classroom and be able to actually program drones, do different missions and challenges as well. Teaching them algorithms, loops, hoops, how to actually do math concepts, teaching them the curves and making the drone do certain functions. We also get into variables and conditions. I like to teach variables. I like to teach variables as as something being in a house, and you have to tend to get that. This one is the one we've been working with most now with middle school students, and we're working with the Doherty County school system, and we've been doing this virtually as well. And the students get to get a Circuit Scribe drone, and the drone is we allow us to teach the electronic portions of the drones and allow us more of the electrical and computer engineering teaching, getting students into that. And the aerodynamics, we get into teaching weight and mass for students in the force and acceleration. So students learn how the drones thrust. They learn the different technical terms that we would see in the industry. That's where the students learn the different flying techniques as well when they actually build the drone. After they build the drone, learn how the electricity works with the drones going back and forth with the electricity and the electrical components, how the propellers and the motors spin together, what makes them spin, how they actually spin. We teach all of that in the what we call the Drone Building 101 curriculum. And many of our teachers in those ask, what standards do we cover? Right now, we're in the ISTE standards mainly, and we're looking at the CTAE standards to see how we can build the curriculum to match the CTAE standards as well. And the current standards in the 21st century are just the basic standards in the 21st centuries. And then we look into the Common Core standards as well. And you can read more about this on our website as well. Here is an example of what we did before COVID. We would go out to the different organizations and go out to the different schools and work with the students. I've worked with elementary and middle school students, and I saw a question earlier about the teens and children. There is a difference between elementary and middle school children. Your elementary school children do have a lot more energy than your middle school, than your teens. The teens, you have to keep them busy, keep them active. And as Megan stated with the children, she gives them different jobs. I do the same thing with the middle schools as well. You may have your pilot, your engineer, your safety officer, those different titles as well. For our 2020 implementation, being that we went virtual with a lot of our stuff, we did a lot of virtual summer camps with the middle schools and the school systems and different camps as well. So what we added in there was drone seminars. We did the Drone Build 101, the Intro to Drone Blocks, and the Circuit Scribe. All of those things were actually done over virtual. And then we also incorporated Zoom and engineer sessions as well. Here's an example of how we actually set up our Zoom. So we set up our Zoom, and we have our teachers teaching, and then we have the curriculum. The curriculum is built out in the Google Classroom. I'm looking to build the curriculum in other platforms such as Canva and Blackboard, build out zip files for those platforms as well. And then this is the setup of the Circuit Scribe. So we use just a basic phone to record so that the students can see us building the drone and us testing the electricity of the drone, as well as us putting the drone together. What I'm currently working on, and you can sign up on my website for updates, is I'm working on 2 books. One is What Are Drones? And that is going to be the basic what is a drone type deal book that you could use with your students. And it is going to be a workbook, more so just than a reading book that students will be able to work through. Be able to label the parts of the drone, be able to understand the terms and the safety terms of drones as well. And then I've developed in the last stages of developing a drone coding book that will go with the drone block curriculum, where students will have the lessons and activities, and then they have their missions and challenges that they'll go through in programming drones as well. And that's all I have for my presentation. Is there any questions? I thank you for listening, and I will stop sharing so you all can ask some questions if you have any.
LaQuata, we have a question. Can you add other teachers to your Google Classroom? This person was saying that she'd love to tap into your resources.
I do have a Google Classroom that's off of the school domain that I can add teachers to, so teachers can actually see how the classroom is set up.
Okay. Would you be able to share that information in the Q&A
Yes.
after your session?
Yep. Yes.
Perfect. I don't see any other questions yet. It's a perfect opportunity if someone wants to post one. Okay, and I don't see any other ones. That was a really, really intensive overview of what it is that you do. I think that you pretty much covered every question that everybody could have thought of. So thank you so much for that, LaQuata.
You're welcome.
Yeah, thank you very much, LaQuata. And I just wanted to add or emphasize a few things that both Megan and LaQuata talked about. When you decide on how many drones to purchase for your classroom, it's critical to know that every child must have a job. That's exactly what I found as well. If they don't have a job that's meaningful, they're going to start dropping out. I've been doing robotics and I've been doing drones for a long time. And if they don't feel like they're making a significant contribution to the team, they generally don't want to be on the team. So make sure that however you organize your classroom, make sure that every child has a meaningful activity to do. Otherwise, they're not going to be happy with how it goes. If you're doing it as a camp or if you're doing it as an after-school program, they will probably drop out. So I highly recommend, I wanted to emphasize those types of things. And then I also wanted to emphasize the dollar store. The dollar store has your hula hoops. The dollar store has the noodles, the pool noodles. The dollar store has a ton of things you can use for your obstacle courses, if that's what you want to do. And obstacle courses are a wonderful way to teach students how to fly. I think you'll learn once you get into drones fairly quickly that one of the ways you can learn to fly is by using sims. And simulators are good, but I have found that kids learn better if they actually have a drone and fly the drone. So having a very inexpensive drone is almost the same cost as purchasing a sim, and possibly better with regards to teaching students the basics of flying. The forces involved, what is it? Something freedom. That's a good engineering term that has I've missed. But the yaw and the pitch and the roll, and to teach them all of those types of things is can be done very easily with very inexpensive drones. And I recommend that you teach them how to fly that way.
Excuse me, Ken, I would like to add that your comments coupled with LaQuata's presentation, they've kind of stimulated a few more questions.
Oh.
So for LaQuata, do you track your students after middle school? How are they doing as far as continuing in a STEM path in high school?
And that's a real good question, because I work with a program called Gear Up here in Dougherty County, and we started with the 6th graders, and we've only been doing this 2 years now, We started with 6th graders. We have an eighth. We had an 8th grade class as well, and now they're in 9th grade. So we started with the 8th grade class, and they actually did the drone free fly. And now that they're in 9th grade, they're doing the circuit scribe, build the drone. And hopefully in the 10th grade year, I can move them over to the dual enrollment program that we have at Albany State University, where they can get into what we have at Albany State, because we're close to the airport. We have it as an unmanned aircraft repair certificate. It's a technical certificate, and that's what we're looking at doing for the pathway. That's my vision of that pathway.
Nice. And do you also take your programs out into the community as well, or are they strictly school-based?
A lot of my activities are actually community-based with the Boys and Girls Club, the YMCA, and then the school's after-school programs.
And this next question, I think a lot of educators can probably relate to. So most of the students in my drone club want to be the pilot and are not interested in those other jobs. Do you suggest they change jobs occasionally or keep the same job?
I have them rotate. So maybe depending on the class, if it's a class with the Boys and Girls Club, if I partner them up with 3, then I have 1 to be the engineer, 1 to be the pilot, and then 1 to be the safety officer. And then they have a certain 30-minute time frame that we may switch them out, and then they rotate.
Thank you. Let's see. And we also have one about parents. And how do you deal with parents who may have questions or safety concerns?
With the safety concerns of the parents, I definitely explain to them that the drones can be a safety hazard if not flown in an open area. And in teaching the students after school now virtually, I teach them to get what we call a safe zone. And the safe zone is about a 10 by 10 area where there's no TV, no breakable components, no lamps, no mirrors, things of that sort. So if the drone was to go out of control, it would be able to hit a wall and not hit something that would be breakable.
That makes a lot of sense. Thank you.
Okay, so now I'm going to go on with the high school. So thank you very much, LaQuata. I really appreciate it. If you can respond to the emails, that would be great, or the questions. Yes, degree of freedom, that's what I was looking for, the many degrees of freedom. So there's up and down is a degree of freedom, side to side is a degree of freedom, yaw is a degree of freedom, and then pitch and roll are a degree of freedom as well. So let me share my screen. Whoops. Did I overshoot? I did. Okay. So this is the drone curriculum. What I think you're going to find as you look at different curriculums and working with drones is that there is this spectrum. I talked about it earlier today, but there is this spectrum that you should be aware of. There is kind of the elementary school, and then there's the university at the other end. In the elementary school, they do very basic stuff. They use smaller drones. They focus on flying. They generally have very inexpensive drones. It's often individual, and the drones are small. At the other end of the spectrum, there is the drones are generally very complicated. They require a team instead of individuals, lots of kids doing it with specialized roles. So they're not just a bunch of kids doing the same thing. They're doing very different things. And once again, it's very important to have a team, and everyone on the team has a very important job. they generally don't focus as much on flying as designing. So designing becomes your focus rather than just being able to fly from one place to another. Designing means affecting the software, affecting the propellers, changing out the motors, understanding what the motors can do, and what more powerful motors can do, what propellers do, what small propellers do versus big propellers, and the effects that that has on things like your batteries. And then there's programming. And then it also includes things like adding things to your drones. What happens when you add things to your drones? And I was very impressed to see that in Megan's presentations, they were trying to add things to their drones and then be able to fly them. And if you do that, you'll find that adding things to your drone is going to modify the flight dynamics of the drone, and it's going to cause issues that you have to compensate for, either through software or through something else. The drones that are used at the university are generally very expensive, and they are very large. So you have lots of people working on a single drone, and they all have a lot of work to do, and they all do very specialized things. So that's kind of the spectrum that you can move through when you decide how your curriculum looks. So in high school, it's shifting more toward design. It's shifting more toward a more expensive quadcopter or drone. It's shifting toward a larger drone, and it's shifting toward more academics. So a drone type that's typical in the high school is something that looks like this. So there's a number of interesting things you can see on this. This is the flight controller. This is referred to as a PixHawk. A PixHawk is an open source flight controller. It has a number of inputs and outputs along its rib here. They go to different parts of the drone. They receive input from sensors. And it's a really nice open source flight controller. Now, what that means is that it is free for you to look at, to work with, but there's a lot of companies that sell a PixHawk type of controller. They should say that it's a PixHawk type of controller when they do that. This also has a big mast and with a GPS on top. So this is meant for being outdoors. So another spectrum you could go by is indoors versus outdoors. Most drones these days in industry, if you're going to do some sort of an authentic task, is going to be outdoors. Almost all of the drones these days that are in industry are outdoor drones, delivering things, picking up things, moving from one place to another in the outdoors. So a very typical sensor on most drones that are going to be used in the outdoors and that are going to be used in general have a GPS system connected to it. This drone is an NXP. I don't know if it has a camera anywhere on this, but they generally do. This is where the antenna is. You can manipulate putting your different things in different places on the drone. Once you do that, it throws the drone's balance off, so you have to readjust for those types of things. It's got some nice powerful motors, large propellers. This will cut your finger pretty badly if you are not careful. So these are not only more complicated, but they're also more dangerous. You definitely are wearing glasses, and you do not fire this sucker up if you're anywhere close to it. So they often will take off the propellers when they're working on it in a live mode or an in situ type of mode. Take off the propellers. You'd have to watch your kids very carefully. You'd probably have to do what shop teachers are real good at doing. They make their students sign a safety pledge, take a safety test, and then do a safety pledge. And if they fail that test, then they can't touch the rover or the drone. So this is one type. This is another type. This has a camera on it. This has a infrared camera on it. So it has more sophisticated sensors. So, and it has very powerful motors, very powerful propellers that will cut you badly. So this is a really powerful system with lots of nice sensors, and it can go a good distance, and it can stay in the air for probably about 30 minutes, whereas the small drones can only stay in the air for about 10 to 15 minutes. So moving up to high school, you end up with these types of things. In high school, the content you can teach physics, you can teach chemistry, you can teach computer science, you can teach career and technology classes, and you can teach a lot of things in math, including algebra and geometry. So in physics, you can use drones to teach about forces. There's all of Newton's forces. There's the forces that are working against each other, like thrust and what you've got thrust and friction, and then you've got gravity and rise. There's all kinds of forces, and they're all paired up. One force is always matched with another force, and that's Newton's, what is it, third law of physics. For every action, there's an opposite and equal reaction. And then you can talk a lot about energy, where the energy is, electric energy versus combustion energy, how the energy goes into a motor and causes the motor to spin. But if you spin the motor, it will actually create energy electric energy that will go down the wire. So your motors end up being dynamos that can either create energy or take in energy. There's a lot you can do with optics and the cameras. There's a lot you can do with the sensors. There's some real interesting simulations online with IR cameras and what you can see with IR cameras. They're wonderful for doing search and rescue type of things. They're wonderful in disaster scenarios when you need to find people or gas leaks or things of that nature. There's a lot you can teach in the radiant spectrum with regards to radio waves and Doppler effects and all sorts of other things. Physics is really a wonderful way to use drones. Drones can be used in physics classes quite a bit. In chemistry, you can talk about batteries. You can talk about the difference between engines and motors again. Engines are a controlled chemical reaction where you've got, that is almost exactly the same chemical reaction that is part of respiration, which means it's exactly what we do to get energy. It's the same processes, it's the same chemicals. It's water and it's CO2. When you combine them, they produce sugar and let's see, you add sugar and oxygen and you get water and CO2. So it's the exact same chemical equation. Then you can talk about energy density. There are some batteries that are very good for very short sprints. And then there are other batteries that are very good for a long-term run and will last for longer and will give you a longer flight time. Then there's a lot of things on material science with regards to building your frame, your airframe. So you can talk about carbon fiber, and you can talk about aluminum, and you can talk about plastic and some of the things you can put into 3D printers. So there's a lot of chemistry you can touch on. There's lots of computer science and career and technology that you can put into a curriculum. There's block coding that goes up to Python coding that goes up to C coding. So you can get into very, very deep coding if you so choose. And then in career and technology classes, there can be an electronics class that will have more than enough to work on with drones, aerospace technology classes, engineering classes. They're all, drones are all wonderful in those classes. In math, there's lots of applications for algebra, geometry, pre-calculus, and calculus. There's a bunch of fun activities you can do that have to do with drones. You can build a barometer. Every single drone that goes outside has a barometer in it. That's the same thing as an altimeter. If you haven't built a barometer, you might want to try that. All you have to do is to get a jar and a balloon, stretch the broken balloon over the jar, and you will start to see that the air pressure inside of the jar is changing compared to the air outside. And you can see how barometers work and why they work the way they do. You can use gyroscopes. The gyroscopes are cheap and easy. You can add you can have the big gyroscopes that you can watch how they move and how they have gyroscopic stability, so that the software inside of the drone can know when the drone has moved and when it needs to get back on target on its path, on its flight path. And you can actually find a bunch of these little ones, electronic gyroscopes that you can put in and connect to some really inexpensive microcontrollers, Raspberry Pis, microbits, Arduinos. There's a lot of different sensors you can add to those to make them to see what they can do and to get the readings from them and to analyze the data that's coming from them. Then you can always use paper airplanes and paper helicopters. There's a whole site for paper helicopters. All you have to do is Google it, and you can do paper helicopters, and that creates a wonderful, fun opportunity to have a little competition in your classroom that's really, really cheap. All it costs is a piece of paper. Then you can do a lot of activities on center of gravity, how an object behaves as if all of the gravity is in a single point, and you can do some really fun things with that. Any kind of a high school curriculum would do those things. You can program drones. You can add payloads to drones to mess them up, add a new sensor to drones, conduct a survey with a drone. Now, that doesn't mean you drive your drone to other people and ask them questions. That means that you're actually flying in a specific path over an area, and then you can actually get a topographic survey of an area. Or you could fly over an area and find all sorts of things. You can fly over an area and see heat signatures if it happens to be a disaster zone. You can see potential hazards and other types of things. They're very good for surveys and other activities like that. Let's see. You can follow something like a pipeline, and you can fly in formation. I don't know if you saw Biden's acceptance speech, but they had drones at the fireworks and the acceptance speech. Did you guys see that? Really good drone presentation. But flying drones in formation is a very difficult thing, but a very useful thing for advanced drone people, drone teams. So the way that is probably the best way to teach drones in the classroom is by preparing for a competition of some sort. And the way you can do that and the reason I recommend doing that is that most competitions at the high school level are intended to be design challenges that take a long time to complete. They are generally team-based, and there's lots of different jobs for students to take advantage of. They generally have an authentic theme, and they are long-term projects. If you do all of those things, you are doing things that industry really wants you to do. So this is where you get the collaboration and creativity and cooperation and collaboration, cooperation, communication, and creativity. When you get the 4 C's of the business and workforce desires and capabilities. So highly recommend you, if you're doing this in the high school, get into a good competition and work all of these things. I have seen teams of teachers do drones in the classroom where you have a CTE teacher and a physics teacher and a chemistry teacher and a computer science teacher all working together to work on a competition. And that makes for a very powerful learning experience for all of their students and actually for the teachers as well. So that's what I have for high schools. If you've got any questions. Yes, Quindell asked, do you have any leads for competitions and projects? Stay tuned, and we'll be talking about competitions in the next session. Any other questions? So I just went over, sorry about that. If anybody anyone else has any other questions, please just put them in the Q&A and I will answer them as quickly as I can with regards to the high school competitions. I mean, high school curriculum. But thank you very much. And that ends the curriculum breakout session. And now we're going to move straight into the